And now we return to more graphing. All right, so we have another cosine of x. So let's go ahead and start by marking just our original cosine points. There. Cosine starts at 1, goes to 0, goes to, no, that was right, -1, back to 0, and then up to 1. Okay, so let's look at what we have here. All right, so we have a 1/2 in front, so eventually that is going to squash the graph vertically. And then this is written x/3 minus pi/3, but we need to factor this so we can clearly see the b value that's going to cause the shrink and the h value that's going to make the horizontal phase shift. So x/3 is the same as 1/3 x, so I'm going to factor out 1/3. X times 1/3 is x/3 minus pi times 1/3 is pi/3. So there we go. All right, so our period is 2 pi over b. B is 1/3. Which means this is 2 pi times 3, which is 6 pi. So that 1/3 is stretching the graph. Then we have the minus pi here. So inside lies. So instead of, it looks like it should go negative, so it's going to go positive. So this is going to go right pi. So our phase shift is right pi radians. All right, the amplitude is just whatever number is being multiplied to the trig function. And then they asked for the midline. So since this graph doesn't have a vertical shift up or down, the midline is the same as the original function, which is the x-axis. But the equation for the x-axis is all the points that share y equals 0. Okay. So we have a new period. We're going to go like, we deal with the period first. So right now it's still at 0, 1. And of course, the graph paper I have is not big enough. Ugh. I'm like, it's really not big enough because we're actually going to shift it right after that as well. You know what? We're going to do this old school way. All right, so if you don't have fancy handy dandy graph paper, call that 1, call that -1. And I marked the half marks because we did determine our amplitude is going to get shrunk here. All right, now Period is 6 pi. I'm just going to mark here 6 pi. Halfway between 0 and 6 pi is 3 pi. Halfway between 0 and 3 pi is 3 pi over 2. And then halfway between 3 and 6 is 4.5, which is 4 times 2 is 8 plus 1 is 9 pi over 2. All right, so with just the period, the horizontal stretch, our graph is at the 1, down to the 0, down to the -1, back to the 0, up to the 1. So it's the same shape. I literally just changed my labels, which is like, it works. Now our phase shift, I now need to take all of these points and move them right pi. So get a little more interesting here. There's our pi. Then 3 pi over 2 plus pi is 3 pi over 2 plus 2 pi over 2. So that is 5 pi over 2. So 3 pi over 2 is going to get shifted to here. 5 pi over 2. 3 pi is going to get shifted to 4 pi. 9 pi over 2 plus pi is 11 pi over 2. Then 6 pi plus pi is 7 pi. All right, so now it starts there, and it's going to be down there. The 4 pi is where it will be down here. The 11 pi over 2 is here. And then the 7 pi is there. So we've changed the period and calculated all of the little subdividing numbers. And that's just a lot of half, half, halfway in between. We did the phase shift, which meant we had to add or subtract whatever that phase shift number was to all of those period points we'd just come up with, those key points. And now our last one is the amplitude. So now I'm going to take my graph and all of the non-zero points are going to get shrunk in half. So where I have it at pi here, now it's going to be there. The 0 point will remain the same. This one will go here. No, it won't. Green lines. Green line. Green line. All right, so all right. And just like make your line just with a little bit of a curve to it, just so it's not like, don't connect the dots with a straight line, just a little bit of a curve. We'll call it good. All right, so there is one period of that ridiculous function graphed. All right, now we have a couple that are asking us to work backwards. So they're giving us a graph and they're asking us to produce the formula that will graph this. So this can get a little weird, but they told us this was a sine graph. So I'm going to use my ruler to draw a straight line close to where the center line seems to be. So that's 2. All right, so we can see we've got a vertical shift of up 2. All right, now sine starts at 0, so this one is starting at 0, so I don't have a phase shift. Our low number is 1, our high number is 3, so the amplitude is 1. So that's our, so we just need to figure out, is there a horizontal stretch? So what's the period? Now, from what I can tell, I check one cycle and that seems to be lining up pretty close to 2 pi. So I'm going to assume that the period is 2 pi. So our B is 1. There's no stretch horizontally, no stretch vertically. So for our formula, we have A sine B x minus h plus k. So our amplitude A is 1, sine. Our B is 1 because our period is the normal size. X minus, there's no horizontal shift. But our vertical shift, it went up 2. That vertical shift is outside the function, so what we see is what we want to put. So it'll be plus 2. So there's our equation for that ridiculous graph. All right, down here, now we got something a little more interesting. This one has been shifted around all over the place. Now it says determine the equation for the sinusoidal function. So when it says sinusoidal, it means it could be sine or cosine. Because remember, they're just pi over 2 units off of each other, so anytime we can write a sine function, we could also write a cosine function. So one of our steps is going to be figuring out, do we want to use sine or cosine? All right, so let's start with the midline. So my high is 1, my low, my minimum is -5. So halfway in between those is 3. So I have to count from one of the extremes, 1, 2, 3. So our midline is going to be y equals -2. So let me go ahead and grab that ruler again. And let's see if we can't just, whoop, there we go. All right. So if we were going to use sine, we would look at where the zeros are. And we see here, this is somewhere between -1 and 0. Estimating where that point is difficult. But if I look over here at the peak, that seems to be lining up with 1. So since our top of the arc is lining up with 1, that means that we're going to use cosine here. Now on our midline, we figure out where that is. That midline is also our vertical shift. So our K is going to be -2 for this graph. All right, the amplitude is, it was 6 all the way across, so it's 3. So our A value is 3. All right. Now let's figure out the period. So I start at 1, down all the way back up, and that repetition appears to stop at 7. So the period is 7 minus 1, 6. Now we're going to use that period formula we've been using. We're just going to do it a little backwards. So remember, our period is 2 pi divided by b. Our period is 6. So this is 6 equals 2 pi over b. I can multiply both sides by b and divide both sides by 6. So my b is pi over 3. All right, now I need to see, did this graph get shifted? So normally that peak is at 0. So this got shifted right 1 unit. So that means right 1 unit, we'd think that would be +1, but it's really going to be -1. So we're going to see x minus 1 in our parentheses. All right, so we have figured out all 4 of the variables. We have our A, we have our B, we have our H, we have our K. All we got to do now is just put it all together and write a formula. So y equals, A is 3. We're using cosine. Our B value is pi over 3 on 2 x minus 1. And then our K was -2, so we have -2 outside. So crazy insane, but there it all is. All right, more of the same here. So feel free to try it out. I'm gonna slap my ruler here, and it looks like between 0 and 8, our halfway value is 4. And now I want to look, is my peak lined up or my valley lined up with a pretty number? And I look over here, no. So I need to use a sine function here. So our sine function starts at 0, 0. This graph here starts at 1, 4. But we can see our midline is at 4. So our k value in our function is going to be +4. All right, we need to figure out the amplitude. So this is half of 8 minus 0. Half of 8 is 4. So our A is 4. Now we've got to figure out our period, so we can figure out B, and then our phase shift. So it looks like our period starts at 1 and then goes to 11. So 11 minus 1 is 10. So 2 pi over b equals 10 times b divided by 10. Oops. So our b value here is pi over 5. And then our last one is our h. So I can see in the graph, this went right 1 unit. So that means we're going to see x minus 1. Right is the positive x, inside lies though, so we do minus 1. So now our full function, we determined we were using sine. So we have y equals 4 sine of, our b is pi over 5 onto x minus 1. Then our k value is positive 4. So there's that ridiculous formula. Okay. I put 5 more on here. I don't know if I'm going to do all 5. Let's do one more and then we'll call this video. So we have negative 2 sine of pi over 2x. So our amplitude is 2. And the negative on A is flipping positive y for negative y. So we're going to flip I'll sometimes write it like this. So the flip is the top for the bottom. And then our period is 2 pi over our b value here, that's pi x over 2. So if I think of that x moving to the side, the b value is pi over 2. So our period is 4 units long. There's no phase shift, there's no vertical shift. And again, we're gonna delete the graph paper because this one, because our period is a number instead of something in terms of radians, that graph paper was not helpful. All right, so halfway between 0 and 4 is 2. Halfway between that is 1. Halfway between 2 and 4 is 3. All right, so there are our key points. This is a sine graph, so it's going to start at 0, 0. And then it would go up to 1, back to 0, 0, down 1, back to 0. But we have an amplitude that goes up to 2. So let me mark 2's. And then they told us it was flipped. So normal sine starts at 0, 0 and goes up. So we're going to start at 0, 0 and we're going to go down. Then back to 0, 0. Then up to 3 and back to 4. And then we just something like that. So as long as it's like a general curvy shape, that's fine. It can be helpful to label the coordinates for the points. So like down here, this is 1, comma, negative 2. This one is 2, 0, 3, 2, and 40. Now, if you're not sure, you can take those numbers, put them in the formula, solve and see what we get. All right, so I'm going to consider if I'll do all of these, but I will do another video for that.